Okay, so section 4.6, we're going to wrap up this talk about rates and ratios by discussing proportions. Okay. Well, how are these concepts related? Proportions and rates and ratios. Well, a proportion is a statement that two rates or two ratios are equal. Okay. So proportion is a statement that two rates or ratios are equal. I don't have a great example off the top of my head, but you could do something like 2/5 is equal to, 154 over 385. Okay. If you actually take these two fractions and divide the top number by the bottom number, you'd find out that they both equal 0.4 on your calculator. Now, is that the way we're going to actually verify whether we have a valid proportion or not? No. Actually, we're going to do something called cross multiplication if we want to verify that a proportion is valid. Now, this is the second time we've talked about something involving the word cross in class. Previously, we talked about cross canceling. Cross canceling, if you recall, was only valid if you were multiplying one fraction by another, or you had a string of fractions being multiplied. But it only was valid to employ or implement if you were multiplying fractions. Okay, and fractions only. Okay, multiplying fractions was it. Adding, subtracting, we needed a common denominator. Dividing, we needed to multiply by the reciprocal. Okay, that was cross canceling. Only valid when multiplying. You just look for common factors from one numerator to the other denominator. Cross multiplication, generally speaking, if you have one fraction that is said to be equal to another one, to cross multiply, you are literally kind of forming a cross here. So it has the same pattern, but there should be an equal sign in between them. Cross multiplication is only valid when you have one fraction set equal to one other fraction. There can't be anything else going on in the equation. You just have to have one fraction on one side, one fraction on the other side, with an equal sign in between. And then you make a cross. Okay, you do that kind of sort of visual tactic again, like with cross canceling. But here you're going to multiply the first numerator to the second denominator and the first denominator to the second numerator. And if these two products are equal, you have a valid proportion. So is 2/5 equals 154 over 385. Is this a valid proportion? Well, to find out, I would take 2 times 385 and see if that's equal to 5 times 154. Well, 2 times 385, I believe, gives me 770. And I think we get the same thing with 154 times 5 as well. So yeah, I get 770 on both sides. So yes, this is a valid proportion. You can verify whether a proportion is valid by using cross multiplication. We're also going to use this technique to solve proportions as well. We'll talk about that a little bit later. First things first, few more basics. This is obviously the symbolic way to represent a proportion. Just stating that one fraction representing either a ratio or rate is equal to another one. Okay. This also has kind of a verbal equivalent, and it would be read as follows. 2 is to 5 as 154 is to 385. Okay. This is how to verbally phrase or state a proportion. We're not going to use this a whole heck of a lot, but they do give you a few problems at the very beginning of this section, emphasizing this idea here. So I just thought I'd show it to you. So 2 is to 5. So kind of using the 2 to 5. So using the word 2 in the middle to describe the ratio here. 2 is to 5 as, basically means equals, 154 is to 385. So essentially using the A to B phrasing for your ratio or rate, and for replacing the equal sign with as. So A is to B as C is to B. Okay. So let's use these ideas here. We should be able to do a number of problems on page 266. So let's start with problem 4. Problem 4. This is where they give you kind of the verbal statement of the proportion. They say 9 is to 11 as 54 is to 66. You can say this is valid. I mean, if you multiply 9 by 6, you get 54. Multiply 11 by 6, you get 66. All they want you to do, though, with this is simply take this verbal phrasing of the proportion and translate it into symbols. So in other words, you'll take the first ratio or rate that they give you, in this case a ratio, and set it equal to the second ratio or rate that they give you. And that's all you have to do for a problem like that. Nothing too earth-shattering there. What about number 6? A little bit more verbose, but the same concept, really. They say 16 parking spaces is to 3 stores, as 48 parking spaces is to 9 stores. How would I write problem 6? How would I express this proportion in symbols? Well, again, I'm going to take the first rate or ratio mentioned. In this case, it's a rate. The 16 parking spaces to 3 stores. I'll just call it spaces on the top. We'll do stores on the bottom. And they say that this is proportional to or equals or as, however you want to phrase that middle part, 48 spaces is to 9 stores. So again, take the first rate or ratio they give you, express it as a fraction. Again, if it's a rate, be sure to include units. Okay. And then set it equal to the second rate or ratio that they give you. Okay. Number 12, just slightly more interesting numbers here, but the same idea really. So they say if it takes 2 1/4 yards of material to make 1 skirt, it will take 9 yards to make 4 skirts. So it sounds like more of an assertion, but really they do have a proportion couched within there. So the first rate they give you is 2 1/4 yards is to 1 skirt. As, what do they have? 9 yards is to 4 skirts. So, yeah, a very different way of wording it, but you can still rephrase it as a typical proportion. 2¼ yards is to 1 skirt, as 9 yards is to 4 skirts. Okay. So, but again, that's pretty basic stuff, really. Just don't fudge the order of the numbers that they give you, and you should be good to go. First number is the first numerator. Second one is the denominator. Third one is the second numerator. Last one is your second denominator. All right. What about the next groups of, well, it looks like we give you 2 groups of problems. Really, you're doing the same thing. Problems 15 through 24. They give you an apparent proportion. Maybe it is, maybe it isn't. They want you to determine if it is a valid proportion. Let's begin with problem 16 at the bottom of page 266. So you see 4 is to 7 as 28 is to 49. Well, how can we unravel this mystery? How can we determine if this is truly a proportion or not? Well, as I alluded to previously, you want to cross multiply. Take the first numerator and multiply it to the second denominator. See if that is equal to the first denominator multiplied to the second numerator. I think we're going to find that it is. I think each of these is equal to 196. Okay. So yeah, this is a valid proportion. So basically just write yes or no for the answer, or equals, not equals, depending on the case. So if you just want to say yes, that's fine. I think technically in the book they have either equals or not equals for the answer. You can just write yes or no for those respectively. It doesn't really matter. So yeah, number 16 is a valid proportion. What about problem 22 at the top of page 267? Is that a valid proportion or not? Okay, so here we have 13 is to 37 as 15 is to 39. Based on the structure of these fractions, I strongly suspect the answer is no. But again, how do you verify? How do you know for sure? You cross multiply. We are going to be doing this until we are blue in the face in this section. Okay, so take 13, multiply it to 39, and see if that is equal to 37 times 15. Well, 13 times 39, I want to say is, what, 507 maybe? 27, carry your 2, 11. Multiplying by 1 doesn't change anything. So yeah, we get 507 for 13 times 39. However, I think this is going to give us 555 over here if we multiply 37 by 15. So 5, carry the 3. 15 plus 3 is 18. Multiplying by 1 doesn't change anything. Yeah. So, question mark, and the answer is no, not equal. So again, you can just write no. You don't necessarily need to do the equals or not equals where you do an equal sign with a slash through it. I think it's more typical if they do it like that, but it doesn't really matter. Yes and no is probably the easiest way to just phrase the answer. Yes, it is a proportion. No, it is not. Okay. But if ever you are in doubt and want to verify, you've got to cross multiply to kick things off. See if the two products on each side are equal. If they are, say yes. If not, say no. Now, very important kind of algebraic concept we are going to learn here is how to solve a very basic equation using what's known as the multiplication property of equality. Don't worry too much about that. We're not going to get too formal with this. But bottom line, we've seen this kind of notation where you have, say, 4x. Okay. This means that you are taking the number 4 and multiplying it to whatever the value of x is. Again, x represents a number. We just don't know its value right now. But if we stipulate that this happens to be equal to something in particular, we can actually solve this kind of equation for x. How? Well, some of you may know because you may have had this in your past. But right now I know what 4 x's are equal to. I don't really want to know what 4 x's are equal to. Kind of like a unit rate. Who cares how much you can drive on 4 gallons of gas? You really want to know, what do you get for each gallon of gas? I don't care how much money I'll make in 4 days. What would I make per hour, So I don't care that 4 x's are equal to 128. I just want to know what 1x is actually equal to in this case. So what's going on here again between 4 and x? You're multiplying technically. I know we don't show it, but it's just a convention. It means 4 multiplied by x. How can I undo this multiplication by 4? Well, what operation undoes multiplication? It's division, right? I mean, if I take something like 3 and I multiply it by 5, yeah, that gives me 15. What if I wanted to undo that? Well, I could just divide by 5. I could divide by whatever I multiplied by, and that would give me my original value back. So if I am multiplying by a number and I want to undo that, I can just divide by that same number. Okay? So if you have an equation like 4x equals 128, and you would like to solve it just so you can figure out what 1x is actually equal to, you can do that by undoing this multiplication by dividing by the coefficient, 4. Now, where does this multiplication property of equality come into play? Well, the equality bit is that whatever you do to one side of your equation, so when you have an equal sign relating two things, you have an equation. You have a statement of equality between two different quantities. Okay, so you've got a left side to the equation and a right side to the equation. I have currently divided the left side of the equation by 4 because it looks expedient. It looks like it's going to be useful. These 4's will cancel out, as we talked about in section 4.4. Okay, we can cancel those out. We've also talked about it in the multiplication section on fractions. These 4's cancel out. Here's a problem. I have manipulated this side of the equation in a certain way. Now, kind of like when you were building equivalent fractions where you had maybe 3/7, and you're like, oh, my LCD, my least common denominator, is 42. So yeah, I've scaled 7 by 6, but you would get an imbalance or an inequality, if you will, to occur if you did not follow that up by scaling the numerator by 6 as well. Okay. So a lot of people say it's like you have a teeter-totter here. You've got 4x on this side, you've got 128 on this side, and they're equal. Okay, you're at complete equilibrium here. No one's throwing one side off to the other. But what if you suddenly divide this side by 4 and you took the weight over here and made it 1/4 of what it was? Well, this guy's going to come crashing down. Kids are going to go flying off. Parents are going to be screaming. It's not a good situation. So you want to keep the teeter-totter in balance by, whatever you do to this side, you have to do to this side. Okay, so if you divide this by 4, you've got to divide this by 4 as well. This will keep the equation in balance. Okay, so I'm just kind of start everything over again from scratch. I've got an equation, 4x equals 128. Okay, that's great that I know what 4x's are equal to, but I really just want to know what 1x is equal to. Is there a way I can solve it? Yeah. Because we're multiplying x by 4, I can undo this multiplication by 4 by dividing by 4. Great, right? Take any hypothetical example, it'll work. If you start with a number and you multiply it by something, and then you immediately divide by that same something, hey, you're back with what you started with. So I'm multiplying x by 4, I follow it up with dividing by 4, I'm going to be back where I started with x. And that's great. Only little problem I need to be concerned with is that whatever I do to one side of the equation, because it looks useful, I need to make sure to do the same thing to the other side of the equation. So I've also got to divide 128 by 4. And if you divide 128 by 4, you get 32. Okay, so this is one of the most basic kinds of equations to solve in math, where you have a number multiplied to a variable and you know that that's equal to another number. How do you solve for the variable? You divide by the coefficient. Not just on this side, but both sides of the equation. You will divide by the coefficient on both sides of the equation. Okay? That will solve the problem for the variable. Okay? Check time really quick. All right. So, why does this come into play with proportions? Well, the real useful aspect of proportions is that typically you'll often know 3 out of the 4 parts of a proportion, and there's really a missing piece that you aren't interested in. And they just kind of ease you into this with problems 25 through 36 before they dive into the story problems. So let me do a few examples from 25 to 36, and then in the second half of this section we'll talk about the story problems. So page 267, problem 26. We see the following proportion, and it's got an unknown value in one part of it. They say that x is to 10 as 6 is to 5. Now, some of you might be easily able to deduce the answer to this just by following the scale here. 5 times 2 is 10, so 6 times 2 is 12. And that's great. Not every proportion is going to have numbers nearly this easy in it. So I'm going to show you a systematic way of always being able to solve for the missing piece of a proportion. The first thing you need to do is to cross multiply. Get rid of the fractions and get this looking like an inline equation, if you will. So we have x times 5, which we more commonly write as 5x. That is equal to 10 times 6. Okay. I know most of you guys know it's 60, but again, I'm going to slow play this a little bit because numbers won't always be this easy in some of these problems. So x times 5, or 5x, is equal to 60. After you cross multiply, you should get, an equation that looks like what we've discussed in these last couple examples here. But again, I don't want to know what just 5x's are equal to. I've only got 1x up here. I want to know what 1x is equal to. Well, I can undo this multiplication by 5 by dividing by it. And that's great. That gives me x. But to keep this equation in balance, on the left side of the equation, I've divided by 5 because it looked to be expedient or, fit for the purpose. But to keep this equation in balance, I want to do the same thing on the other side. I need to divide this amount by 5 as well. And that gives me the answer of 12 that some of you might have been able to see from the get-go. Okay? So, the way to solve a proportion for a missing piece, first step, cross multiply. If you have some more difficult numbers, you'll probably need to do some multiplication here to figure that out, whether you do it on your calculator or do it by hand. But then make sure if you're working this out on like an exam or in your homework that you show this step here. Absolutely critical. Show that you are dividing the quantities on both sides by the coefficient of the variable. Okay. Keep in mind, coefficient is just a fancy word. That means that's the number I'm multiplying to the variable. Okay. What about problem, let's see, let's do problem 30. So problem 30, we have 15 is to 21 as x is to 14. Sorry. I'll get it right, don't worry. Sorry, brain's always a little bit ahead of my mouth. My mouth is ahead of my brain, one of the two. Okay, so 15 is to 21 as x is to 14. So how are we going to solve this for the unknown value of x? Always, 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 first step, cross multiply. This will get rid of your fractions. We have 21 times x equals 15 times 14. Excuse me. Okay. If you have any products to evaluate, go ahead and do so. 15 times 14 happens to be 210. And now for the coup de grace. We're multiplying x by 21. I would like to undo that because I don't want to know what 21 x's are. I need to know what just one single x is equal to. Well, I can undo that multiplication by dividing by 21. I just need to make sure to do the same thing on the other side of the equal sign. I need to divide 210 by 21. These will cancel out, obviously by design. I didn't want that coefficient there to begin with, but I have to legitimately find a way to remove it. And I can legitimately undo multiplication by dividing, but to keep this whole equation in balance, I've got to divide by 21 on the other side. Well, that will just give me 10 for the result. Okay. And for one last example, before I come back and do story problems, let's do problem 36. So here, this is clearly a proportion with rates in it. You say you have n miles is to 15 gallons as 16 miles is to 3 gallons. You must be riding a lawnmower or something because this is not very fuel efficient. Nevertheless, how do we solve this? Just ignore all of the labels with rates. Okay, they won't come into play. Technically, if you were to do what they call a unit analysis on this, all the units would work out and cancel out just the way they need to get this to work. So when you cross multiply, in case you have rates in your proportion, just ignore the units and work with the numbers and variables only. So we have n times 3 equals 15 times 16. Or, more commonly, 3n equals, and if you multiply 15 by 16, you get 240. Okay, and again, this is why cross multiplication is useful in this case. It takes this equation with fractions in it, gets it down to a nice inline equation that we can better digest and interpret and manipulate. So we're taking 3 times n, that's great. I just want to know what 1n is, so I'm going to divide by that 3. But to keep the equation in balance, on the other side of the equal sign, I'm also going to divide by 3. Over here, I know these will cancel out as we've talked about. I just get n, or 1n. Over here, I've got to do the division. Well, 240 divided by 3 is 80. And in this case, this represents 80 miles, because n was in terms of miles, or being measured in miles. Okay. So that's another thing. Technically, if you are using rates to describe your proportion, which is going to be most common as we go through these story problems, make sure to carry your units with the answer. Okay. So I'll come back for part 2 with story problems.